What if I told you that right now, at this exact moment, an object from another star system is passing through our solar system, and it might be carrying life? Not signals, not machines, but actual living organisms, forms of life that could have been planted billions of years ago by a civilization far more advanced than ours. Stay with me, because what comes next might completely change how you see your place in the universe. For decades, scientists have debated a simple but powerful question. Did life begin here on Earth, or did it arrive from somewhere else? But recent discoveries about an interstellar object known as 3 Atlas have forced researchers to consider something even more radical. Could this object be a kind of cosmic garden, a vessel designed on purpose to spread life across the galaxy? And if that's true, then the real question becomes, who planted those seeds? Before we go deeper, if mysteries like this pull you in, make sure you stay until the end, because what I'm about to share is not just speculation. It's built on real data from powerful instruments like the James Webb Space Telescope and insights from some of the most respected astrophysicists in the world. By the time this story unfolds, you may start to wonder whether we're just observers of cosmic history or part of an experiment that began long before humanity existed. To understand what might be happening with this interstellar visitor, we need to go back not to the beginning of this object, but to the beginning of life itself, because your origin story might be far stranger than you think. Here's something that could completely shake your understanding of where you come from. You might, in a very real sense, be Martian. This isn't a joke. Scientific evidence suggests that life on Earth may have actually started on Mars and then traveled here. Billions of years ago, massive asteroid impacts struck the surface of Mars, blasting rocks into space. Some of those rocks eventually made their way to Earth, and we know this happened because scientists have found Martian meteorites right here on our planet. Now think about the timing. Around 4.2 billion years ago, Earth was still a molten, hostile world, but Mars, being smaller, cooled faster. That means it may have had liquid water and stable conditions long before Earth did conditions that could support life. If microbes formed there, they could have been launched into space inside those rocks and later landed here, seeding life on our planet. One meteorite in particular revealed something incredible. During its journey from Mars to Earth, it never heated beyond temperatures that microbes could survive. That means life, at least in its simplest form, could endure a journey across space. And when scientists studied hundreds of modern microbes to trace back to a common ancestor, they found something surprising. That original life form appeared very early in Earth's history, almost too early to have evolved from scratch. The timeline fits almost perfectly with the arrival of Martian rocks. Coincidence? Maybe. But the more we learn, the more this idea begins to make sense. Scientists call this process Panspermia, the natural spread of life through space via rocks and debris. And as strange as it sounds, the physics checks out. Life is far more resilient than we once believed. Microbes can survive extreme radiation, vacuum conditions, and even remain dormant for millions, possibly billions of years. But here's where the story takes a turn most people never consider. Natural panspermia, as fascinating as it is incredibly inefficient. Most of the rocks blasted off a planet never reach another world. They drift endlessly through space, lost between stars. And even when a few do make it, the odds are still against them. Many burn up in atmospheres, others crash into oceans where any life inside is instantly destroyed. In other words, while life can spread naturally, it rarely succeeds. So now ask yourself this: if random chance can do this, even at a low success rate, what would happen if an intelligent civilization decided to do it on purpose? What if, instead of relying on luck, they engineered the entire process? What if they built objects designed specifically to carry and deliver life across the galaxy? Not random rocks, but intentional vessels. Carefully planned, precisely executed. This idea has a name: directed panspermia. And it's not some fringe concept from science fiction. It was seriously proposed by Francis Crick, one of the scientists who helped uncover the structure of DNA itself. He suggested that life on Earth might have been deliberately seeded by an advanced extraterrestrial civilization. At the time, most scientists dismissed the idea. It felt too speculative, too difficult to test. There was no way to prove it. But now, for the first time in history, that might be changing. Because this interstellar object 3 Atlas is giving us a rare opportunity to examine something that didn't originate in our solar system. And when scientists pointed the James Webb Space Telescope toward it, they expected something familiar. A typical interstellar comet should show simple compounds: water ice, carbon dioxide, maybe carbon monoxide. Standard materials formed in the cold regions between stars. But what they found was far more complex and far more intriguing. The cloud of gas and dust surrounding 3 Atlas contains water, carbon dioxide, carbon monoxide, and methane. On their own, these molecules don't prove anything unusual. They exist throughout the universe. But here's the key detail. Every one of these compounds plays a role in biological processes here on Earth. They are directly linked to metabolism, to energy cycles, to life as we know it. Still, that alone isn't enough to raise alarms. But then came data from another observatory, Spherex, and this is where things start to get strange. It detected organic molecules being released from 3 Atlas at a rate that is about 14% of its water output. That's not a trace amount. That's a significant release of complex carbon-based material, exactly the kind of chemistry associated with life. And then came the real mystery, methane. This is the detail that has scientists losing sleep, because methane didn't behave the way physics says it should. It was only detected after the object passed close to the sun. Before that, nothing. No signal at all. And that's a problem. Methane ice is extremely volatile. It should begin evaporating long before other gases like carbon dioxide. If methane were sitting near the surface, we should have detected it early in the observation process. But we didn't. The only explanation that fits is that the methane was buried deep inside the object, shielded from solar heat until it got close enough for that heat to penetrate inward. Only then did it begin to escape. But even that explanation raises more questions than it answers, because carbon monoxide, an even more volatile substance, was detected earlier, which means something doesn't line up. The chemistry is off. The behavior doesn't match what we expect from a natural comet. And that's when one of the world's leading astrophysicists asked a question that sent shockwaves through the scientific community. What if the methane isn't geological at all? What if it's biological? Because here on Earth, methane is deeply connected to life. Microorganisms known as methanogens produce it as part of their metabolism. Animals release it. Decomposing organic matter generates it. Wherever there is life, methane often follows. So what if this isn't just trapped gas finally escaping? What if something inside 3 Atlas woke up when it felt the sun's heat? What if organisms that had been frozen for billions of years suddenly became active again and started producing methane? It sounds unbelievable. It sounds like science fiction. But the data refuses to fully align with any simple natural explanation. And right now, scientists are trying to figure out what this anomaly really means. Because in science, it's not the expected results that change everything. It's the anomalies. And this one might be pointing to something far more unsettling than dormant alien microbes, because there's another possibility, one that some researchers are beginning to take very seriously. What if 3 Atlas isn't just carrying life by accident? What if it was designed to carry life? What if this object is not just a visitor, but a message in motion? Stay with me, because in the next part, we're going to explore exactly how something like this could work, and why some scientists now believe we should use objects like this to spread life beyond Earth ourselves. What if 3 Atlas isn't just carrying life by accident, but was built to carry it on purpose? Let's explore that idea carefully, because once you see how it could work, it becomes difficult to ignore. Imagine you are part of a highly advanced civilization. You've mastered space travel, explored nearby star systems, and discovered something both exciting and frustrating: planets that could support life, but don't yet have any. Now you face a choice. Do you simply observe these empty worlds and move on? Or do you take action and give them a chance to become alive? Humanity already shows this instinct in smaller ways. We build monuments, write books, and pass on our genes to future generations. All of it is driven by the same goal: to leave something behind, to continue beyond our own existence. But an advanced civilization might think on a much larger scale. Instead of leaving behind structures, they might leave behind ecosystems. Entire living worlds that grow, evolve, and possibly even become intelligent long after the original creators are gone. This isn't just philosophical thinking. Scientists have actually outlined how something like this could be done, and interestingly, objects like 3 Atlas may be the perfect tools. Here's how such a system could work in practice. An interstellar object enters a star system just like 3 Atlas is doing right now. A nearby civilization detects it early and calculates its path. Then they launch a spacecraft designed not to explore the object, but to modify it. This interceptor catches up with the comet and deposits a payload either on its surface or deep inside it. That payload is the key. It contains life in its most durable forms: microorganisms, spores, maybe even genetic material carefully selected for survival. But that alone isn't enough. Space is cold, dark, and hostile. So the payload also includes a heat source, often imagined as controlled radioactive material, not as a weapon, but as a long-term energy supply. As this material slowly decays, it produces heat. That heat creates a small, stable environment inside the object, just enough to keep microbes alive, possibly even active. Over millions or billions of years, Those organisms could survive, adapt, and even evolve within their tiny, protected habitat. Meanwhile, the object continues its journey through interstellar space. Eventually, it approaches another star system. As it gets closer to the new star, the heat begins to affect its outer layers. Ice starts to sublimate, turning directly from solid to gas, releasing dust and particles into space. And with that dust come the microorganisms, scattered like seeds carried by the wind. Some of those microscopic travelers might land on planets with the right conditions. Most won't survive, but a few might. And over long periods of time, those survivors could multiply, evolve, and potentially give rise to entirely new ecosystems. One mission, leading to countless worlds becoming alive. Now here's the part that makes this more than just theory. We could do this ourselves. Right now, 3 Atlas is currently passing through our solar system. Its closest approach to Earth is happening within a time frame that, in theory, we could have used. If space agencies had acted immediately after its discovery, it would have been possible to launch a fast response mission, an interceptor designed to reach it, study it up close, and maybe even interact with it. But we didn't. We weren't prepared. There was no spacecraft ready, no mission plan waiting, no system in place to respond quickly. By the time the opportunity became clear, it was already slipping away. And that's what makes this moment so frustrating. We are observing 3 Atlas. We are collecting valuable data using tools like the James Webb Space Telescope. But observation has limits. Telescopes can only tell us so much. They can analyze light, detect molecules, and reveal patterns, but they cannot physically confirm what's inside. To truly understand this object, we would need direct contact. We would need to collect samples, bring them back, and examine them in detail here on Earth. That chance is gone. 3 Atlas is not bound to our solar system. It's on a hyperbolic path, meaning it came from interstellar space and will return there. In a few years, it will be too far away for even our most powerful instruments to detect. It will disappear, carrying its secrets with it. But this isn't the end of the story. Because 3 Atlas is not the first object like this, and it won't be the last. Stay with me, because in the next part, we'll look at what this means for the future and why scientists believe we are about to enter a new era where these interstellar visitors may no longer be out of reach. But this isn't the end of the story, because 3 Atlas is not alone. Before it, there was Oumuamua in 2017, a strange, elongated object that moved through our solar system in ways we didn't fully understand. Then came 2I, Borisov, in 2019, which looked more like a traditional comet but still carried material from beyond our star system. Now, with 3 Atlas, we are starting to see a pattern. These visitors are not rare accidents. They may be far more common than we once believed. Astronomers now estimate that objects like these could be passing through the inner solar system regularly, perhaps even once every year. The only reason we missed so many before is simple: we weren't looking carefully enough. Our detection systems were limited, our surveys incomplete. But that is about to change. A powerful new observatory, the Vera C. Rubin Observatory, is being designed to scan the entire sky every few nights. That means any fast-moving, faint interstellar object will have a much higher chance of being detected early. And early detection is everything, because if we can spot these objects soon enough, we can act. Scientists are already working on plans for rapid response missions spacecraft that would be ready to launch on short notice the moment a new interstellar visitor is discovered. These missions wouldn't take years to plan. They would already be built, waiting for the right moment. Once launched, they would use advanced propulsion systems to catch up with these fast-moving targets. They could fly alongside them, analyze their surfaces, study their chemical composition in detail, and possibly even collect samples to bring back to Earth. This is not science fiction anymore. The technology exists. What's missing is commitment funding, coordination, and the decision to make it a priority. And 3 Atlas is helping to push that decision forward. The unusual chemical signatures, the strange methane behavior, the presence of organic material, these are not small details. They are signals that something about this object does not fully fit our expectations. And when science encounters something that doesn't fit, it forces us to look deeper. Researchers are now seriously discussing missions that could intercept future objects. Some proposals even go further, suggesting that we don't just study these visitors, but use them. Imagine sending our own biological material, carefully selected microorganisms, on one of these interstellar travelers, not as an experiment of curiosity, but as a deliberate act. A way to extend life beyond Earth. It raises difficult questions. Should we do it? Do we have the right to seed other worlds with life? Could we interfere with ecosystems that might already exist in early forms? These are not simple decisions. But the conversation is happening, because whether we act or not, the opportunity is real. 3 Atlas is already leaving. Every second it moves farther away. Soon, it will be beyond our reach forever. But the next object, and the one after that, will give us another chance. The difference next time will be whether we are ready. And that brings us to a deeper question. Not just what these objects are, but what they mean. Because if even one of them turns out to carry life, whether naturally or intentionally, it changes everything we thought we knew about our place in the universe. So now we arrive at a moment that feels almost unreal. An object from another star system passes through our cosmic neighborhood, carrying the building blocks of life at the exact point in history when we finally have the tools to detect and analyze it. Coincidence? Maybe. But it's a coincidence that forces us to think differently. Because this isn't just about one object, it's about a pattern, a possibility, and a message that may not be spoken in words, but is written in chemistry, motion, and timing. 3 Atlas is giving us a glimpse into something much larger, the idea that life might not be limited to isolated planets, but could be part of a much broader process. A process that spreads, adapts, and evolves across the galaxy. And if that's true, then we are not just observers of this process. We are participants. Think about what we've learned so far. Life on Earth may have arrived from elsewhere. Microbes can survive extreme conditions and long journeys through space. Organic molecules are present on interstellar objects. And now we've seen behavior like the delayed release of methane that doesn't fully match simple natural explanations. None of this proves that 3 Atlas carries life, but it opens the door. And once that door is open, even slightly, it changes how we look at everything. Because now we have to consider that life might not be rare. It might not be isolated. It might be widespread, moving quietly between stars, waiting for the right conditions to take hold. And if that's happening, then the next step becomes a choice. Do we remain passive? Do we continue to watch these objects come and go, collecting data but never reaching out? Or do we take a more active role? Do we build missions that intercept them, analyze them up close, and finally answer the question of whether we are alone? Or do we go even further and begin sending life outward ourselves? Because that option is no longer theoretical. The technology is within reach. The only limits now are our decisions. We could become a species that spreads life beyond its home planet, not through colonization in the traditional sense, but through something more subtle, planting the seeds of biology in places where it can grow naturally over time. A legacy that doesn't last centuries or millennia, but millions, even billions of years. Long after Earth changes, long after the sun evolves, long after humanity as we know it is gone, life could continue because we chose to act. But with that possibility comes responsibility. We must understand what we are doing. We must consider the risks, the ethics, and the consequences. Because once life begins on a new world, it cannot simply be undone. That's why moments like this matter. 3 Atlas may leave us with unanswered questions. We may never know exactly what it carried or what was happening deep inside it, but it has already done something important. It has shown us what is possible. And it has made one thing clear. The next time an interstellar visitor enters our solar system, we will have a choice to make. And whatever we decide will shape the future not just of humanity, but of life itself. And now we reach the point where everything comes together not as a conclusion, but as a decision. Because 3 Atlas is already on its way out. It's leaving our solar system, slowly fading into the darkness between the stars, carrying with it answers we may never fully uncover. We observed it. We measured it. We analyzed its chemistry using instruments like the James Webb Space Telescope. But we never touched it. We never opened it. We never truly knew what it was. And that's the reality we have to face. This might have been our chance to directly study an interstellar object up close to confirm whether it carried life, or at least the strongest evidence we've ever seen. Instead, we are left with patterns, anomalies, and unanswered questions. But maybe that's not a failure. Maybe it's a signal, because what 3 Atlas has really given us is something far more valuable than a simple answer. It has given us direction. For the first time, we are no longer guessing blindly about interstellar visitors. We know they exist. We know they pass through our solar system. And now, we know they can carry complex chemistry, possibly even the ingredients for life. That changes everything. It means the universe is not silent, not empty, not inactive. It means something is happening out there, whether its natural process is playing out across billions of years or something more intentional. And this is where the question becomes personal. What do we do next? Do we continue as we always have, watching from a distance, collecting data, and letting these rare opportunities slip by? Or do we prepare ourselves for the next one? Because there will be a next one. With new systems like the Vera C. Rubin Observatory scanning the sky continuously, we are entering a new era of discovery. An era where interstellar objects are not once-in-a-decade events, but regular occurrences. And next time, we won't have an excuse. We can build missions that are ready to launch within days. We can design spacecraft capable of intercepting fast-moving targets. We can finally collect samples, analyze them directly, and answer questions that have remained open for generations. But beyond exploration, there is another path, a more ambitious one. We could choose to participate in the same process we are trying to understand. We could take the concept of directed panspermia, the idea first seriously discussed by Francis Crick, and turn it into action, not as speculation, but as a deliberate mission. We could send life outward, carefully selected microorganisms designed to survive extreme conditions, placed into interstellar objects that will travel farther than any spacecraft we could build alone. Seeds of biology carried across the galaxy over unimaginable spans of time. It wouldn't happen overnight. We wouldn't see the results in our lifetimes. But that's the point. This is not about immediate reward. It's about legacy on a cosmic scale. Because one day, billions of years from now, somewhere far beyond our solar system, life could emerge on a distant world, and it might trace its origins back to a decision we made here, right now, and maybe, just maybe, that's exactly how it happened to us. Maybe somewhere long ago, another civilization faced the same question. Maybe they saw an opportunity. Maybe they acted. And maybe we are the result. We don't know. Not yet. But that's what makes this moment so powerful. 3 Atlas is gone, or soon will be. But it has already done something extraordinary. It has forced us to confront the possibility that life is not just something that happens, but something that can be shared, something that can be sent, something that can travel. The universe may not be speaking to us in words, signals, or equations. It may be speaking through events like this, through objects that arrive silently, carrying the raw materials of life, appearing just as we become capable of understanding them. Coincidence? Maybe. Or maybe it's an invitation to step beyond observation and into participation. Because the story of life in the universe is still being written. And for the first time in history, we are in a position to decide whether we simply read that story or become the ones who write the next chapter.